In this video, we're going to look at the alkylation of acetylide ions. Alkynes are unique because our terminal alkynes are acidic, which means when we pull off that terminal hydrogen, we can turn the alkyne into a really strong nucleophile called the acetylide ion. This is one method of how we can extend carbon chains. If we look at this first example, we have one butene, and if we treat it with sodium amide, we will get a deprotonation. Sodium amide is one of the only strong bases. It's one of the strongest bases, and that's why it can deprotonate. Bases that are weaker are unable to, so usually when you see this reaction, you'll see it with sodium amide. When this reaction goes through, we get the exact same molecule with the triple bond, except there was a heterolytic cleavage here. This ion grabs the hydrogen, and there's a heterolytic cleavage. The carbon retains both of the electrons that were involved in the bond, thus giving us a strong nucleophile. Now, if we interact this strong nucleophile with, say, CH3Br, or any alkyl halide, we will do an SN2 attack on the carbon, and the bromine will leave, and we'll be left with CH3, C with the triple bond, and then we extended it by one carbon. We made two pentyne from one butene. Let's look at another example. If we start with ethyne, and again, we react it with our very strong base, NaNH2. These ions are going to dissociate, and then we're going to deprotonate our alkyne and get CH, C-, and then we'll also get our NH3. But for this reaction, the more important part is the CH and the carbon with the negative charge. If we have another alkyl halide, say in this case we have 2-bromobutane, we're going to do our SN2 attack, even though this one's secondary, and we're going to get our butane with our ethyne attached as well. This reaction that we just looked at would occur slowly, and there's a higher chance that elimination would take place instead. However, since it's not a tertiary alkyl halide, we will still see the SN2 product to some extent. But primary or methyl halides would work much better. Another interesting reaction we can do with this ethyne is the exact same thing as before. And we'll get our strong nucleophile now. And we'll deprotonate this. And if we react with whatever we had before, our methyl bromide, with our backside attack, we will get the same thing we saw in the first example. But if we have our excess sodium amide, it can deprotonate the other side. And then we're left with another strong nucleophile that can attach to some other chain via the SN2 mechanism again. This is a really important mechanism and one of the first that you'll learn of how to extend carbon chains. If you found this video helpful, please consider liking and subscribing, as it really helps the channel out. If you want to see more organic chemistry videos, there should be the playlist up on the screen now. Thank you so much for watching.